Alright, welcome back to Turing Complete. I hope that I got rid of the weird humming sound that was in the start of the last one, but so let's back where we left off. Last time we did all of the basic, remember to pan, the basic logic gates. We did not, nor, or, and of course, NAND, the holy, and always on. The next we'll finish the rest of the basic logic gates, but these ones are all a little more complicated. As you know, these tests culminate in building a functioning computer. Species that are capable of finishing are considered sentient by law. This is the main reason we don't eat you afterwards. Output on the second tick only. So we need it to only output on if this one is on, right? So that is input 1. So when this is on, it needs to be on. But if this one is also on, or essentially, this needs to be on and this needs to be off. So that's and, right? If this is on and if this is off, well, we know it's off. If it's off, then this will output on, right? So if this is off and this is on, this turns on. Turn this on, it goes off. This off, off. See, now the only way that it's on is with this exact desired output. Then, bam. And let's run that. Perfect. All right, XOR gates. Last level, we built a circuit that was on when we were at the second tick. This level builds a circuit that is on when we were at the second or third tick. So now, this is the XOR, the exclusive OR gate. If you remember the OR gate, right, it's on if either of them are on, right? But the XOR is if either of them, but not both of them, see? So in here, it's the same as an OR gate. So if we say, well, we know it's the same as an OR gate for most of it, right? But it's different, right? When these are and, right? If we look at this, that's on. No, they're both on. Hold on, wait. I don't think I've done anything here. Both on. No, I still just need an exclusive. Oh, I need a NAND. Yeah. See, now this, they're both on. Oh, yeah. So then we AND this. Right? Had the right idea. See now, see, they both, there has to be OR. It has to be the OR check, right? Because that's this, these is the OR. But also it has to not be this, right? And since this is NAND, not NAND, NAND, right? So we need it to be OR and not AND. That's what this AND is. And that's this. So if we then run this, perfect. We've unlocked the XOR, and we unlocked an entry on truth tables and universal gates. Truth table, we already talked about this. The tables of input and output, which are used everywhere throughout the game, are commonly known as truth tables. Input and output will be represented with variable names, like in algebra. Instead of using colors, you'll see them represented as 0 or 1, false, true. On, off is another common universal gates. Turns out you can build all the yeah, we talked about that. Yeah. Modern computers are not built entirely out of just one gate, but you know, they will make as many components as possible out of NAND because they take less area. All right, onward. Bigger OR and bigger AND. We'll do OR first. Create an OR gate with 3 inputs, right? So if any of these are on, right? It's just a 3, like I said, it's just an OR, but with 3 inputs. So, well, you know, we're going to start with at least this OR, right? And if this is on, it works. If this is on, it works. It only doesn't work when this is on. But if either of these is on, it does work. So we just need to add another OR to include this, and then works, works, works. I guess I don't need to check every computation manually. But as you can see, it's pretty straightforward to make OR gates into a 3-input. Same thing with AND gates. Yep, create an AND gate with 3 inputs. So if we try that same approach, see, this will only be on but we need all 3 of them to be on for this gate to output. So we know that this gate will only output if both of these are on, and this gate. So that will be the only way this is on, and then if this one is also on, bam, it works. Run it through, works at every combination. And last, the XNOR. This is, yeah, the inverse of the XOR, right? So if you'll notice that since this is flipped, if you remember, the only thing we have, that's not an XOR, this is. Only thing we have to change is by inverting the output. Perfect. And that is the rest of the basic logic gates, right? After this, we'll talk about binary erasers, double trouble, different numbers of signals, and circular dependencies as we get into the arithmetic and memory portions. Or actually, which one is? Yeah, the bottom is the title. So yeah. So that was a short one, but I want to get as much of this stuff in one as I can. So thanks for watching, and tune in next time.